Welcome to Crashcast Java, the podcast where we dive deep into Java concepts and make them accessible to developers of all levels. I'm Victor, and today we're joined by our resident Java expert Sheila. We'll be exploring the fascinating world of priority blocking queue and its performance in Java. Sheila, can you give us a quick introduction to what we're talking about today?
Absolutely, Victor. Today we're discussing priority blocking queue, a powerful and versatile data structure in Java's concurrent collections framework. It combines the functionality of a priority queue with thread-safe operations, making it an excellent choice for multi-threaded applications that need to process elements in a specific order.
That sounds intriguing. Before we dive deeper, can you explain what a priority queue is for our listeners who might not be familiar with the concept?
Of course, imagine you're at an airport and they have a priority boarding system. First-class passengers get to board first, followed by business class and then economy. A priority queue works similarly. It organizes elements based on their priority, ensuring that the most important items are processed first.
That's a great analogy, Sheila. So how does the priority blocking queue build on this concept?
Well, priority blocking queue takes the priority queue idea and makes it thread-safe. This means multiple threads can safely add or remove elements from the queue without causing data corruption or inconsistencies. The blocking part comes into play when the queue is empty or full. Threads can wait for elements to become available or for space to free up.
I see. So it's designed for concurrent use in multi-threaded applications. Can you tell us a bit about its performance characteristics?
Certainly. Priority blocking queue offers O log n time complexity for insertion and removal operations, where n is the number of elements in the queue. This is because it uses a heap data structure internally to maintain the priority order. However, it's worth noting that the actual performance can vary depending on factors like the number of threads accessing the queue and the contention level.
Interesting. Are there any specific scenarios where priority blocking queue really shines?
Absolutely. Priority blocking queue is particularly useful in scenarios like task scheduling systems, where tasks need to be executed based on their priority. It's also great for implementing producer-consumer patterns where consumers need to process high-priority items first. For example, in a customer support system, VIP customer requests could be prioritized over standard requests.
That makes sense. How does it compare to other concurrent collections in Java?
Great question. Compared to other concurrent queues like linked blocking queue or array blocking queue, priority blocking queue offers the unique ability to process elements based on priority. However, it doesn't have a fixed capacity, which means it can potentially grow very large if not managed properly. In terms of performance, it may be slower for simple FIFO operations compared to linked blocking queue, but it excels when priority ordering is required.
I see. Are there any common pitfalls or best practices developers should be aware of when using priority blocking queue?
Definitely. One common pitfall is assuming that the elements will always be processed in strict priority order. In reality, if multiple elements have the same priority, their order isn't guaranteed. It's also important to implement a proper comparator for custom objects to ensure correct prioritization. As for best practices, it's crucial to choose appropriate timeouts for blocking operations to prevent deadlocks, and to consider using the drain-to method for batch processing of elements, which can be more efficient than removing elements one by one.
Those are great points, Sheila. As we wrap up, could you summarize the key takeaways about priority blocking queue's performance?
Certainly, priority blocking queue offers thread-safe priority-based element processing with logarithmic time complexity for core operations. It's excellent for scenarios requiring prioritized task execution in concurrent environments. However, developers need to be mindful of its unbounded nature and potential impact on memory usage. When used correctly, it can significantly improve the efficiency of multi-threaded applications that need to handle prioritized workloads.
Thank you, Sheila, for this insightful discussion. Before we sign off, could you mention a few advanced topics related to priority blocking queue that our listeners might want to explore further?
Absolutely. For those who want to dive deeper, I'd recommend looking into 1. Custom synchronization techniques for fine-grained control over concurrent access. 2. Performance tuning and benchmarking. priority blocking queue in high concurrency scenarios. 3. Exploring alternative priority queue implementations like the skip list-based concurrent skip list map for different performance characteristics.
Excellent suggestions, Sheila. That wraps up our episode on the performance of priority blocking queue in Java. Thanks to all our listeners for tuning in. If you enjoyed this episode, don't forget to subscribe to Crashcast Java for more in-depth discussions on Java concepts. Until next time, happy coding.